Okay, everybody, welcome back to Unit 2, Part 3. We'll be talking about the kinetic molecular theory today. The kinetic molecular theory explains the behavior of gases. And obviously there are four or five parts to the kinetic molecular theory that you need to know. And that's that particles are in constant random motion, in which they move in straight lines until they have collisions with each other or with the walls of a container. That any collision between particles is elastic, meaning no energy lost. Particles do not stick to one another, and the speed of particles is directly related to the temperature of the system. So, with that being said, we'll give you a few tidbits of information to help you remember what is happening with the changing variables and how they affect pressure. So, pressure, if we look at three containers of equal size, how would we draw particle diagrams to represent differing pressures? And the way we would do that is by drawing our particles, and then because pressure is particles colliding with the walls of a container, we would want to draw our smashies. So let me change the stylus here to be a little bit smaller and change the color to make it a little bit more obvious. But in system 1 here, particles are moving, so we'll put some tails on there, and then particles are also colliding with the walls, so there's a smashie at the top. As we get an increase in pressure, obviously particles are still moving, but we're going to have multiple smashies. And then as pressure increases even more, we have movement, but we have smashies occurring in multiple locations. Okay. Okay, moving on, let's talk about volume. And what we're going to do here is, obviously, the volume is the space occupied. So, small volume, larger volume, and then largest volume. Okay, next variable is temperature, and at this point I'm going to leave out the box, the system, and I'm just going to draw the actual particles. Okay, and as we increase temperature, how do we represent that with a particle diagram? And we do that in the following way. All particles are always in motion, so they may have a single tail, or swooshy. As temperature increases, we add a second tail to show that particles are moving faster, and then we end with three tails showing that particles are moving very fast as temperature is at its highest. Lastly, we have N, which is the number of particles, and this is simply we need to add more particles to the system, and we do that by adding particles. It's pretty simple, and by knowing the relationships between each of these things and how they affect pressure, we know that increasing the number of particles would increase the pressure of the system.